All right, guys, let's talk about case 9, challenge 1. We're going to go ahead and head over to the Geniverse, open up our case log. We are on the apprentice level, case 9, challenge 1. It looks like it's another quill challenge. That means we'll need to write a response using the journal tab. Can a father pass his nose spike trait on to his children? Okay, so we've got a new trait to look at, a new phenotype here. Looking at the mother, it looks like she doesn't have this. The nose spike is this little thing up here. So mom doesn't have this, dad does. Let's take a look at their chromosomes. So I'm going to pair these up in their homologous pairs. So there should be one of each color. And they should have the same genes on them. Okay, so here are her nose spike genes. She's got 2 genes for no nose spike. Let's pair dad's up. Now remember, dad's his sex chromosomes are not homologous because he's a male. He's XY. Okay, so this is interesting. The nose spike allele, it looks like, is on the X chromosome. The mother has 2 copies. No nose spike, no nose spike. The dad has 1 copy for just nose spike. So let's go ahead and look at their genotypes for these 2 phenotypes here. As we just found out, this is a different type of trait than we've looked at before. This trait is on a sex chromosome rather than a autosome, or the chromosomes responsible for coding for the different organs within your body, right? The sex chromosomes, they're responsible for determining gender. But that X chromosome, since it's present in both males and females, the X chromosome has genes that correspond to things beyond gender. In Drake's, one of these traits is the nose spike. So because these alleles are represented on the sex chromosomes, we need a slightly different way to represent their genotypes. So we can assume that since mom has 2 alleles for no nose spike, that trait is the recessive one. And to show that that trait is connected to the X chromosome, we represent it as like a little exponent on the X chromosome. So both of her X chromosomes have the recessive allele for no horns or no nose spike. So what does that mean about dad? He has a nose spike. Well, that means that his X chromosome must have the dominant allele. His other sex chromosome is a Y chromosome with no allele that pertains to nose spikes at all. This presents an interesting dilemma because your gender now has an effect on the ability for the Drake to inherit this trait of nose spike. So traits that are found on the x-axis, they have unique expression patterns because the different genders have different numbers of these alleles. Females of the species have 2 Males only have one. So let's go ahead and put dad's alleles across the top of the Punnett square here. Mom's along the side. And then we'd fill out the inside. So this Punnett square is going to be the key to answering the question for this round here, which again is, can a father pass his nose spike trait on to his children? Remember, your goal is to see if you can make both of these target drakes. So a female with a nose spike and a male with a nose spike. You're going to have to determine whether or not that is actually possible to make these two drakes. And it all comes down to interpreting this Punnett square. So use this Punnett square as part of your evidence for your claim. This combination of a mother with no nose spike and a father with a nose spike, can it result in a male drake with a nose spike? Why or why not? Submit your claim, get your quill, and then come back to see the next video.